That's a small chat, isn't it? Hello. I thought I should continue where we stopped last time. Right? So we are on again. What more is there to say, really? Isn't such what engine should? So welcome back to the other physics stream. Yeah, I will be physics. Yep, I know, cool stuff. So tomorrow we have an examination on physics. It's pressure, sorry, pressure and density, as well as Archimedes principle. I don't know. Let's just get a pencil here. So let's just start. I'm gonna start just by reading a bit about it, I think. Actually, Archimedes. If I can find it now. See if I can find it. If I just move this paper for now. In love. Yeah. Of your glass to mine, as we drink, we would lock eyes, so we could disregard ever having too much. And yeah, okay, so physics. Let's hear. Here, 5, chapter 5, density and pressure. 115. Ba ba da ba bow, ba da ba ba da. Da da da. Yeah, density equals mass divided by volume. Yeah. And the symbol for density is this weird Greek sign, rho or something like that. Mass divided by volume, yeah. And that is kilo per cubic meter, which is also, okay, yeah, density. Yeah, that's density. Bam, 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 bam. Okay. Pressure. Yeah. And alright. Yeah, that if you have a table, obviously the force of the pressure is equal. Wait, no. Yeah. Hello, Joshua. I had to continue, man. I just couldn't stop like that, right? We had to continue, man. Definition of pressure. So pressure equals the pressure force, which is equal to the normal force, which is also equal to Newton, Fg, divided by the yeah, so area, yeah, okay, sure. Yeah, and that's Pascal. I'm gonna write this down, actually. I think I should write this down so I remember them better. So, what we have to remember here. So, firstly, is that density try my best to write that equals mass divided by volume. What my guns sound like? Actually, what my gun sounds like? Well, you mean like this kind of gun, or do you mean like more of a? I don't really. Is that what you meant? Yeah, that's something important, and as well as that. That's true. And then we got pressure. This is density. This is the Greek letter for density. And then Tryggkraften is the same as P equals the applied force, the pressure force, which is equal to the, how can I say, it is equal to the gravitational force of the book, the Newton. I think? No, I'm not gonna do such shit, bro. I can't, bro. I can't, bro. pressure equals force divided by area. Area, how do you say that? Why I'm not gonna do the third sheet, bro. I can't. And this we answer in what now again? Density is kilo per cubic meter, yeah. Whilst pressure is just Pascal. Not PSI, you Americans. Just go and eat your bananas or something. Yeah, so that's basically this so far. Density equals the mass divided by the volume, and we answer this in kilo per cubic meter, and pressure is just the applied force from the book, which is equal to its newtons divided by the area. Oh, this is not. Do you have math, Joshua? No, this is just physics. Physics, math, that's fun. You wanna know something fun? What is it? It's what is it now again? It's like what is it now? When you start nausea, you're gonna have to do this formula as well. It's like X is it like what is it? No, it's not. That's wrong. I'm sorry. This you're gonna have to do this. You don't have to do this, Joshua. This thing, yeah. Very funny, right? Yeah, very fun. Anyways, physics. Keep on with that. It's not math. Oh, my fucking god. Timer, bro. But it's standing. Shoes were made for dancing with someone else. Don't we move this space? Alright. Anything else here? Yeah. Okay, no, so that's the trick, which is fluid. Pressure from fluids, often water, obviously, but could be whatever. Alright, so when you push down, yeah. Okay. You're not smashed. First, you're gonna make some exercises. Pressure equals Hayden times the density times G is like just G. Does that mean like what is that G? That's such a weird G. I don't really like that. It must be just gravity. My polarity too. Hello, Joshua. Hello. How are you today? Okay. Yeah, this is different depths, this formula. What's up, Joshua? What's going on? Meow, meow, meow. Down, 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 now, bow, meow. Down, down, down. Okay, so yeah, the pressure depends on the height of the vestibular. Yeah, because you know pressure when you dive down, the pressure is much stronger deeper down than it is in more shallow depths. And okay. Air pressure is as well. Peace. Shout out to Trelch also, by the way, and shout out to Joshua, shout out to Guardman, shout out to Chevy, shout out to Dotty Bones, shout out to more. What is Muradi's channel? What is Harisa's channel? I don't remember his name. It's like something something. I don't know. Oh, and we got Idiana Dasnardian here as well. This is interesting. Maybe not interesting, but it's important. So, Idiana Dasnardian. Okay, so it's good artist, Ado. I don't think this is. It died again. Fudge. Ah. Okay, it's time for Archimedes princip. Okay, this is basically okay. I'm gonna get another book because this is basically the important stuff that it kind of reads here. Shit, these papers. Wait, I'm gonna get another book. Wait a second, guys. Just need to find. Should get another book real quick, but we're back. Got some water. That I almost completely drank. Alright, let's get back to it. Basically, this book, it's kind of more interesting right now, I think. Whatever the other book is telling us, because I don't know. Alright. Let's check the formulas. Because that's what's interesting right now. Basically. What was it, 200 something? Yeah. No? It's not right. Ba 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 ba. Ba ba. Here, pressure. Yay. Hello, Blase. Lester Plaster Brown. Yeah, I had to continue the stream when Joshua left it off, you know? Just had to do it. More here. Ashmi has perceived. That's what's important. What is it? So So, Liftkraften. This is the stuff, I don't know. So, Liftkraften is equals to the density of the surrounding liquid times the volume of the undanträngda vätskan, volymen, volume is which is often written in M3 cubic meters, yeah, times just gravity, really. Can't forget gravity, right? Good to make me feel just like this. What I would do to make me feel just like this. You strangle me. Born in such positions. Listen. Listen. Missing you, wishing was different than what it was. I don't know the lyrics. Alright, yeah. Yeah, that's basically basically I don't think we're gonna have a lot about these ones, really. But the important ones are just these ones, really. So let's solve some problems, right? Shall we do that? Let's do that. Gotta bring this big chunky book outside again. We do some. Oh, near at this. Let's do that. Put this here. I'm just gonna. I'm gonna take another paper to do the. Exercise zone. I need another paper to do the work. Alright, paper. We got a paper, guys. We got a paper. We got a little paper, guys. Let's. Alright. Alright. Let's start. Alright. 1. The density of platina is 21.45 grams per cubic centimeters. And we're going to do this in kilo. Alright. Well, I mean, okay. It's just 41 grams per cubic. Oh, wait, let's died again. Bro, come on. Don't die on me like that. Oh well, so basically I want to make this to kilos and meters. I mean, I think, can we just multiply with 1,000, I think? or divided by 1,000. No. I think that's right. I mean, isn't this just... Then it's supposed to be like 21... This is 21,450 kilos per cubic meter. I don't know. It's... Hey Linus. Continue Joshua's stream because his camera died, so I just kept going. 2. Number 2, okay. Okay, so we got a paper, and it weighs 5 grams. Let's just start by making this into into kilos, really. So this is the same. This is wrong, by the way. This is I don't know yet. That's not. Anyways, papers. Let's convert this to just kilos in the beginning, so it's 0.005 kilos. Alright, and I want to calculate its density. Well, we know that density is the same as well, and the volume is 6.8 cubic centimeters. We also want to convert that, I think, because if we're gonna use it, we want to use SCN answer. So, and then we'll just I don't get. How do you convert? Jesus, am I stupid? How to convert grams per cubic centimeters to kilos per cubic meter? Okay, that was right. So is this really just times 1,000? Times thousands, yeah, so it's literally then the volume. I mean, it sounds weird. So 1 gram per cubic centimeters is equivalent to 1,000 kilos per cubic meter. Maybe, I don't know, made sense probably. I don't know. Let's just follow this then. No, this is just, no. I see. I suck at unit conversion. Jesus Christ, I suck. I don't get unit conversion. I just don't. So 6.8 quadratic cubic centimeters is the same as 0.0000067 no, etc, etc. How, bro? How is that? How is that the same? I just don't get it. How is that the same? Okay, so let's try it. So the density, which we don't know, but the density equals, well, the mass, which is 0.005 divided by 0.0000679. Now we should get the density of this very tiny paper. If we just calculate this, 0.005 divided by 0. 1, 2, 3, 4, 5, 6, 7, 9, which is equals to 7. Well, it's about we can financial this one, I think. So the most we got is 2. No, it's just 1 really. So we can do this 2 then to 700. Well, density is just written. How is density written anyways? It's density. I don't know, density unit is just Pascal less pressure, I know, but I don't know the density. It's just rho. No, it has no this. No, it should have. Kilos. No, it should be 700. I don't know. How is this? I have to check. Is it really 700? It feels off. I don't know. Here, no. First one we did was right, correct. Second one is why do they answer in Grumper? They really shouldn't. They really shouldn't. Well, I think this is, in my opinion, this is correct, because they answered with centimeters, which is something that we don't want to do. Just enheten. For density is kilos per cubic meter. So let's go on to the next one. On the way is a glass with a liquid. Okay, so let's think of this. And this thing here shows 140.5 grams. Well, And then 41 cubic centimeters of the same liquid is poured into the glass, and it shows, so it goes from 1 to 7 1. And what the density? Well, we know that density is the same as mass divided by volume. We know that the mass is, well, we know that the mass is 171 grams. Really, it doesn't, yeah, it's just 171 grams, 100 grams, which in kilos is 0.1713. Kilos. The density is what we're after, but we don't know the volume. Well, we know that when they poured it last time, they poured in 41 cubic centimeters, and that weighed 171.3. So that's basically the volume. But if we think really, what is volume? What is volume? Well, usually it's just balls into your head, really, but we can't use it in this case. But we know. I mean, we can just turn this. So we have this formula. We can just check this around a bit. So we know that volume is the same as that. I don't know the density really too. So basically, I don't know really. The density. No, I'm so wait. I don't think we need it. I don't think. I'm out here. Let's rethink this. So 171. Let's just account for the liquid that was poured in. So we did the difference. So 171.3 minus 140.5. That is 30.7 grams. That's the difference. That's the new liquid that we poured in, which in kilos, if we're talking about that, it's 0.0307 kilos. We know that the volume of this very same share of the substance, we know that the volume is 41. Yeah, and if we just want to convert this to well, meters, we would just need to write, well, that's the same thing as 0. Well, we can keep it this way. No, we can't really. Actually, we don't. Have to convert it to 0.0000005. And then, well, we know that density is equals mass divided by volume. We have mass and volume, so we know that the density of this liquid is equal to 0.0307 divided by 0.000041. which is equal to, if we just calculate this, this. And the least information we have gotten is 2. So if we have to answer with 2 värdeziffror, whatever it's called. So I'll just 750 kilo per cubic meter. That should be correct in my opinion, if I'm not completely wrong here. I mean, yeah, they don't answer it in they don't answer it in they answer it in grams per centimeters. I don't really get that. I don't think. I mean, yeah, if we were to, it would not be this. It just wouldn't. It would just be for 1 centimeters, cubic centimeters. No, here it would be 30.7 grams. I mean, we could do it that way as well. I mean, that would just be 30.7 divided by 41. But you know, it's really the same thing. It just gives us grams instead, but we can then convert that, I suppose. Maybe it's easier. Actually, I think it is actually, yeah. I don't know, I like you to do it in the beginning just to get it straightforward out of there, you know? But, I mean, yeah, it totally, you could. I mean, I think this, I mean, yeah, the answer, yeah, 0.75. Yeah, I mean, yeah. It is also that 0.5, which it's about that grams per cubic centimeter. But they want us to answer in SCN HEAT, which is the scientists' chosen units all over the world to internationally be able to cooperate using the same units, not ounces, not that weird stuff like inches. So let's do next one. A dice of pure aluminum has a side 2 centimeters in mass. Okay, so is it compact or hollow? Well, we know that it has a side that is 2 centimeters, and we know that the mass is equal to 15 grams. Well, I don't know. It has the side of 2 centimeters. What does that mean? Has a side. I feel like that's too vague of an explanation. It has side 2 centimeters and has. I mean, yeah, a dice has 6 sides, 6 faces. I mean, if it has 2 sides, I mean, yeah, I mean that would be. To get the volume would be just 2 times 2, which is 4, and then just 4 times 2, which is 8, and that would just be 8 cm3, and that would be it. And if we want to get the density, I mean, we just have to have mass divided by, so we just have, I mean, we can have grams again, so if we have 15 divided by 8, we just would have whatever that is now, I don't know. 15 divided by 8, it's yeah, 1.75. Well, we only had 1 as, so we just have about 2 grams per cubic centimeters. So it's not hollow, is it? No, it's not. It's not hollow. I don't get why it would be hollow. Which one? Okay, I'm just gonna have a little break here, so I'm gonna go to a break, but I'll be back, okay? We are back, guys. I am back from a short commercial break. I'm gonna stream for about maybe 15 more minutes, and then I'm just gonna continue studying without the stream because it's a bit exhausting, you know. But let's do this, guys. Let's do this. All right. Next question, number 5. So the mass of the Earth is about 5.98 times 10 to the power 24 kilos, and it has the radius of 6.37 something something. M, what does that mean? Big M, small m. What is that? Megameter. What does it mean? 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 Does it mean? Does it mean? What does it mean? What does it mean? What does it mean? Big M, small m. What is that? What is that? It says that the Earth has the radius of 6.37 mm. I don't know what mm is really. Is it megameter? Megabyte is how much now again? Million, right? So. So, basically, well, I'm gonna answer in megameter. I'm not gonna convert that. It's like a million. It's like times a million, and I'm not gonna write that out. So I'm just gonna keep it like this. I could, I mean, do this. I guess 37 times just 10 to the power of 6. To the power of 6, right? I can do that, but you know. So, but let's keep it this. Yeah, I mean, yeah, density is the same as mass divided by volume. We know the mass. We don't know the volume, but we can count. We can count the volume because we know that the volume of a sphere is the same as 4 divided by 3 times pi times the radius to the power of 3. So pi is, let's say, you know, it's 3 point. Okay, so we can rewrite this to let's just say 1.33 times 3.14 times 6.37 to the power of 3. Which is about 4.1866666 times 6.37 to the power of 3, which is in itself 6.37 times 6.37 times 6.37 is, so it's about 4.8 4.186 times 258474853, which then is equal to 1081.97503. This is in what is this now in again? Yeah, the radius. Yeah, this is the volume of the sphere. So this would be, since we've answered this, and yeah, it would be just in megameter. I mean, I guess megameter cubic, I suppose. So we know that density is equal to the mass, which we know, which is 6.37. Let's no, it's not. It's 5 point. Sorry for that. It is 5.98 times 10 to the power 24 divided by. Well, let's say that this, which is the least information we have gotten, is 1. So let's say, yeah, it's about 4 megameter in cubic. So it would be that divided by 4m3. This is my answer. I don't know if that's correct at all. Maybe I'm completely wrong. Probably is. But you know, it is what it is, and keep on going. I was wrong there. I was wrong. I'm gonna keep studying, but guys, I think I'm gonna, I mean, you know, what can I say really? I'm gonna keep on studying, I think. Yeah, I'm gonna keep studying, but I'm thinking I'm gonna end the stream here, but you know, it was fun. It's nice still. I mean, holding myself accountable by streaming is pretty nice. Actually, and maybe I'll do this again sometime. Maybe we should stream a bit more on Crouch. We're not really that active on that kind of uploads or content, but there will be soon a very big, very large project we've been working on that we'll be releasing maybe sometime next week. So stay hyped for that. There's more projects coming down the line, but there's a big one coming, okay? So there's a big one. It's taking a bit more time, and I know it's been a while since the last upload, but it's a good one. It's a real good one. So I think that's it. But thank you so much for watching, guys. Remember to subscribe to Krellish, obviously, and I'll see you next time, guys. So yeah, have a good one.